When subjects were treated with a drug, their systolic blood pressure readings were measured before and after the drug was taken. Results are given in the table below. Assume that the paired sample is a simple random sample and the differences have a distribution that is approximately normal. Use a 0.05 significance level. Is there sufficient evidence to support the claim that the drug is effective in lowering systolic blood pressure? Okay, notice the statement here. So the mu d is the mean value of the differences for the population of all pairs of data, with each individual difference. D is defined as, and here's what we need to know, the blood pressure reading before the drug was taken minus the reading after the drug was taken. So these can get a little tricky. So we're doing before minus after. And so if the drug was effective in lowering the blood pressure, the systolic blood pressure readings, what would we expect if we're doing a before minus after? So think about this. If we're doing before minus after, we're hoping that it's a higher number minus a lower number. And what kind of result do we get if we do a higher number minus a lower number, like 10 and 7? 10 minus 7 is 3. 15 minus 13. So a bigger number minus a smaller number will always be a positive number. So we're hoping that this difference is positive or greater than 0. So the answer here is C. That's tricky. I have to think about that. And I'll sometimes even write big minus small, just so I can get it in my head. If it were the other way around, if we did after minus before, we'd be expecting negative numbers because we're having lower numbers minus higher numbers. So you got to keep that in mind when doing this. That's the hardest part about this entire problem, I think. Now let's go ahead and find the test statistic. And we do that using technology. Do not do these by hand. So open in StatCrunch. Okay, so it pulls it in. I'm going to go to Stat, T-Stat, and Paired. So we'll do before in column 1, after in column 2. We're here the difference. Again, it's mu d equals mu1 minus mu2. So kind of keep that in mind, that this is how StatCrunch will always subtract mu1 minus mu2. If the problem states something else, then make sure you change it. And again, I like to see summary stats, so I'm going to select summary stats for that. You may not be able to see that. So I select summary stats and then press compute. So I like to be able to look at this. So the before was 183.8 and the after was 163.3 from 12 participants. I think that sounds promising. If I didn't even have the p-value and test statistic, I'd say, hey, that looks pretty good. But if I did this again, how likely am I to get a result this extreme, where here the mean difference was about 20.5, right? Well, it's very unlikely, right? It's 0.016 as my p-value. So only about 16 samples out of 1,000 would I see a result this large if the mean difference was indeed equal to 0. Even if there was no difference, I'd see a result this large just by chance. About 16 times out of every 1,000 samples. So I was saying, it's unlikely that's one of those. So I'm going to reject the fact that they're equal and that they're not equal. Wait a second, I made a slight error here, and some of you may have caught that. I'm going to leave this in the video too. It says that they're not equal, but there was a direction on this test, right? So let me go back and edit this and change this to greater than, right? Because I want to match what I'd already talked about. I went too quickly through that. Compute. There we go. Notice we still get the same summary stats, the same mean difference, but now it's even less likely because I'm only going in one direction. All right, so 0.008, only 8 out of every 1,000 samples, exactly half of what I had before, right? Because now everything's in one tail. So my test statistic is 2.8. Let's see, it says around at 2 places, so 2.85. And now identify the p-value. 0.008. Now for the interpretation. The p-value is low, or less than the significance level. Significance level was 0.05. 0.008 is certainly less than that. We're going to reject HO. there is enough evidence, or there is sufficient evidence to support the claim. The drug is effective in lowering blood pressure. Similarly, on the calculator, when I go to Stat and Edit, I need to clear these lists out. So just select L1 and press Clear and Enter. There are a couple ways you can do it to clear a bunch of lists at the same time, but we'll not worry about that. And scroll to the last one, L3, and clear. It's a nice clear list, and then put in the before into L1 and after in L2. Okay, went ahead and typed the list in, and now I want to tell L3 we're going to do L1 minus L2. So I'm going to press second 1 minus second 2, and then press enter. And it goes ahead and creates that list for me. Now I'm going to run a t-test on that L3. So press stat, test, run a t-test number 2. Its data, mu sub 0 is 0. List is L3. Make sure you have that at L3. Frequency, I need to change, leave frequency at 1 and change my mu to greater than. And then go to calculate. We get exactly the same thing we got when we ran StatCrunch. I really want to encourage you to use StatCrunch rather than TI. We have t equals 2.85 and the p-value 0.008. And again, it gives me a quick little summary stats of the sample mean difference, which is about 20.5 with the standard deviation.